Let's calculate slack values graphically. So what we have here is one of the practice problems. We have a maximization problem. The objective function is 2x plus 5y. And so we've represented that with the black line here. Those are constant values of the objective function, 2x plus 5y equals 40. Those are all the points where the objective function is equal to 40. And that is the optimal point because we've increased this as much as possible until it's just barely inside the feasible region. The feasible region is provided by the constraints. We have a constraint 1x plus 2y is less than or equal to 16. We've represented that with x plus 2y is greater than or equal to 16. We flipped the sign of that just to get the color on the outside so that the feasible region, the space that we need to stay inside or on the boundary of, stays white just so we can see it. We're not actually flipping the direction of the constraint of the problem, just the representation on the screen. So we've done that with all the constraints and we're left with our feasible region, and we have the line corresponding with the objective function passing through the optimal point. So we solved the problem, but now we want to find the slack variables and the surplus variables. There's a slack or surplus variable corresponding with each constraint, each inequality constraint, I should say. So the first constraint is an inequality constraint with a less than type. X plus 2y is less than 16. And so for those we put the slack variable because the slack or surplus variable is always positive. And when it's a less than constraint, we call it slack. It's taking up the slack. We want to see how much we want to add to the left-hand side before we get up to the value of 16 when the x and the y are their optimal values. So with x is equal to 0 and y is equal to 8, how much do we have to add in order to make this constraint active, in order to make it effectively an equality constraint? Well, you can see that the point we're at, 0, 8, is right on that line. 0 plus 2 times 8 is equal to 16. There's nothing that you want to add to this. You want to add 0 to this in order to make it effectively equality constraint. It already passes through that line. This constraint is already active. It's already binding. The slack is equal to 0. This constraint here, how much do we have to add to the left-hand side in order to make it an equality constraint? Now this one here, the equality constraint, constraint is not active. This point, the optimal point, the line does not pass through that point. So let's see how far away it is. Well, we can plug the numbers in. 5 times 0 plus 3 times 8. 3 times 8 is 24. So the left-hand side is 24 and the right-hand side is 45. How much do we have to add to 24? What slack value do we add to 24 to make it equal to the right-hand side of 45? We have to add 24. We could find that graphically by adding, say, 10. Okay, it's closer. Plus 20. Plus 24. Oops, it looks like I've done my math wrong. I think 21 is what I meant. Excuse me. We have this point, again, was 0, 8. So 5 times 0 plus 3 times 8 is 24. We have to add 21 to that to get 45. Yep, so 21 is the slack corresponding with this constraint. This constraint was not active. It has a non-zero slack. The first constraint was active already. It was binding already. It has a 0 slack. Okay, let's move on to the third constraint. This is actually x is greater than 0. X is greater than or equal to 0. Sometimes you won't see slack or surplus variables calculated for these non-negativity constraints, but I'm going to go ahead and do it. The concept still applies. So in this case, because this is a greater than constraint, technically we should call it a surplus. How much does x exceed 0? Or how much could we subtract from the left-hand side? What positive value could we subtract from the left-hand side to make it an equality, to make it equal 0? X minus what is equal to 0? So in this case, we see already the constraint is active. The constraint is binding. X passes through the line. X is equal to 0. We don't have to subtract anything from this side. If we subtract 1, it's no longer active. We want it to be active, so we subtract 0 from it. The slack or surplus here, the surplus in this case, I'm often going to call it the slack because I don't really care about the distinction between the two, is 0 in this case because the constraint is active. Now this constraint, you can see it's going to have a non-zero slack because it's not active. The optimal point isn't on the line y is equal to 0. So what do we have to subtract from the left-hand side to make the constraint y is greater than 0 active? Should we subtract 1 minus 5 minus 8? Well, that makes sense, right? Because the point, after all, was 0, 8. It was 8 above the y-axis. We have to raise this axis up by 8 in order to make it pass through the optimal point, in order to make it so that this constraint is active. So on the homeworks, when I ask you to calculate the slack, then what I want you to do is add or subtract on the left-hand side the value that makes the constraint active and show me that the constraint is active. So for instance, if I were asking you to calculate for this constraint what the slack is, then I would say you need to add 21 to it, and you would show that the optimal point was 0, 8. Maybe click on that so I can see that your original constraints, the purple one and the green one and the red one, are still in their original places, but you've added 21 to the left-hand side of the blue one, and now that passes through the optimal point, the solution point. And so I can see that because you added 21, 21 is the slack value.